Hello coders, welcome to my video. In this video, we'll be starting with a linked list. So most beginners starts with array, but arrays have the hidden drawbacks. Today we will explore why linked lists exist in C and what are the problems in the arrays that is being solved by linked list. Okay, so if the array, for example, I have a structure, so I'll take a struct array. Okay, struct array something and then we have ARR, the variable, and we define, for example, 5. Okay. So here we define an array of type structure. So this array is in the form of continuous memory. Okay. For example, 1, 2, 3, 4, 5. Okay. So for example, this structure array is of 10 bytes. Then we will have 10 bytes here, 10 bytes here, 10 here, 10 here, and 10 here. Okay, and the address start from here to here, like these are the blocks and these are continuous memory. So if this memory location is 1, it would be 2, it would be 3, 4, 5. Okay, so there are few strength in these as well. Okay, so we have O1 of notation. Okay, so if we want to take this, so we'll directly go to here and pick this value, whatever is there. Okay, so this is cache friendly thing. So what are the weaknesses of the array? Weaknesses of the array is of constant or a fixed size need to be given at the compile time. So the we'll see insertion and deletion will take O raised to power n, and there is a wastage of memory due to fixed allocation. For example, if on the runtime we need to decrease or increase this memory, we cannot do that because this all memory is predefined at the compile time. So this error is fixed in what you say as dynamic memory allocation. Dynamic memory allocation, in which we have heap and there the same structure if I take, so that is in block. For example, the struct array, whatever is there, is at location 1, for example, and second block of struct array is at location 5, and third block is at location 15. Okay, and so on. So if you take a full memory like this, so there, how to find the interlink if we want to traverse to that memory, or we have to save that data in that memory, so there must be a linkage between them. So that linkage goes from here to here and here to here. So these all the three blocks need to be aligned. So this block, we need to have the address of this block. So if we get the address of this block, we can get the address of this as well as this, because this is connected somehow. This memory is connected. Okay. So the linked list works on this fundamental, in which we can remove or delete or add anything at runtime. So this memory allocation can be done at the runtime as well. Okay. So the problem of this fixed size memory is being solved by this. Okay. But the access of this linked list need to be in sequential order. For example, if you want to go here or get the value, so you have the pointer of this node. So you will go here, then you go here. So more operations are there. So time constraint is there, but still memory is managed very beautifully in this. So one more thing about array is, if that memory whatever is there, this chunk of memory is not there in that RAM or ROM, it won't allocate. Rather, it will find a memory that is greater than this. But it's not the case we say here. It can take, for example, if I have 2 bytes of memory here, 1 byte of memory here, and 3 bytes of memory here, then we can take it using memory allocation, and this memory can be connected like this. Okay, so we need a pointer for this memory only. Okay, so this is how the linked list work. So we have a pointer to this address, and we will traverse through each of the nodes. So these blocks, whatever is there, is called a node. Okay, and these are connected like this. Okay, so maybe this block, each block is of struct array. So let's do it programmatically and find out how linked list is initialized. So let's start with a hash include stdio.h. Then we have int main. Then I'll take return 0 here. Okay. So to define a linked list, we need a structure. Okay. So I'll take the struct. Name of the structure is I will take node node, and inside what I will do, I will take an integer. Here we have a node value. Okay, this is an integer, and for the reference to the next node, we need to have struct node next pointer here. Okay, and if we want, we can have type def of this as well. Okay, so this is a single node. So whatever memory is consumed by this structure, that should be connected to the second block of memory through this next pointer. So this next pointer should have address of the next node, so that that memory is consistent. Okay, so we can traverse to that memory. So here, what I will do, I'll have a node and n1. So this is the first node over here. Okay, so we need to allocate the values to node value of this node is n1 dot. I have node value here. This value I'll take, for example, 2. I'll take this value for this node. And what about this next pointer? This should have the address of the next node. Okay, so we don't have a next node right now. We only have a one node. So I can take one more node. But okay, so what I will do, I will take comma and n2 and to the second node. Now, what I will do, I will take n2 dot node value is equal to 3. So right now, I have two nodes, one with value 2 and second node with value 3. Okay, so I need to connect this n1 to n2. So how to do that? So I'll take n1 and give the address of the next pointer to this node value 2. Okay, so it should be like n1 dot next is equal to address of n2, something like this. Okay, and what about the next node n2? So this instance of the node should be pointed to null. So we are taking a singly linked list right now. So n2 dot next is equal to null. So it should not point to any node. Okay. So if I print the value, so I'll get node 1 value. So n1 I will take, and here I have node value is equal to percentage d. Okay. So here I'll take n1 dot node value. Okay. Then what about the N2 value. So similarly, I'll take N2 value as well. So this is uh, one form. So what if I need to go from N1 to N2? I have a N1 address and I want to go to the N2. So what I will do, I will printf. I have the N1 address. I need to go to N2 and this have node value. I want to get the node value to N1. Okay. So it should be percentage D. Okay. Then what I will do, I will take N1 dot next. Okay. Dot node value. Will it work? So let's see. Save it because this is a pointer. So I'm taking a pointer over here. I will save it. I will run it. Okay. So what you will get, N1 node value is 2. That is correct. N2 node value is 3. That is also correct. Now from N1 you are going to N2. Okay. So you are taking the value as 3. So we are getting the correct value over here. So this way we go on and connect the second node one by one. But this is not the right way to create the node, because as we discussed in the slide that this memory should be dynamic. Okay, so we should use malloc in spite of using the static values. So what, so I will change the static values to pointers. So what I will do first, better I'll take a pointer of this. Okay, and here also I have to take pointer. Okay, then you see it's giving some error. So what I will do is I will point this value to 2. Similarly, I have to take value here. Okay, and similarly here, and what I will do here, I will also point here and save. And though we change this value to pointer value, but still these nodes don't have the memory. So what I will do, I will take N1 is equal to malloc. Okay, then we have size of struct node. Okay, and similarly I will take N2 as well. So I'll copy better this one. Okay, and here I'll take N2, and what I have to here, I have to free it as well. Okay, so free N1, similarly free, because I directly have the address of N1 and N2 right now. So I can directly free it. I don't need to traverse anything right now. So, okay. So I'm getting one error, free. Okay, still lib is required. So let's put hash include stdlib.c. Sorry. Okay, let's save it. And I need to file it. Okay, one more error I'm getting. N1 points to N2 is equal to N2 directly. We don't need the address now. Okay, so let's compile again. Okay, now it's fine. So if I put it again, I got the same value, but through dynamic memory allocation. So this is all about the basic initialization. Okay, let's see in the next video. Thanks.